Okay, I think we need a little more. Well, at least I'm gonna do whether you need it or not. You can watch the video. You can choose not to watch the video, but we're gonna do some more algebraic simplification to use to evaluate the limits. Okay, so as always, let's just start out with the substitution method. Okay, we plug 0 in. What do we get? We get square root of 4 minus 2. So that's 2 minus 2, and h goes to 0. Okay, so we got 0 over 0. All right, we need to do some things. Okay, so what we need to do, we're just not even gonna worry about the limit right now. Okay, we're gonna simplify this function, okay? And I'm gonna do it by using what's called the conjugate. And most people forget about the conjugate. You'll get pretty good. I mean, this isn't the only part of calculus that you'll use conjugates, but in algebra you're pretty much just tested over them, and it's not until advanced math that you actually start to use these things. Okay, so the conjugate is really just the same thing, except I just switched the signs here. Okay, and what's handy about the conjugate is I can use it for simplification purposes, and that's really all it's for. Okay, so what I'm going to do is I'm going to use the FOIL method. So I'm going to go first times the outside times the inside times the last term. Okay, so this first term, this is if I take a number and I multiply it by itself, I square it. Okay, and if I square a square root, that's just equal to x. They kind of cancel each other out. Okay, so just in case you need a little refresher. Okay, so I'm going to do that. I'm going to multiply these together. The square root will cancel out, but always keep it grouped in parentheses, because that's just one number, really. Okay, and it could lead to errors if we don't do it. So, all right, next I'm going to go to the last term, FOIL method. Okay, so that's okay. Now I'm just doing the inner term. And now it's the last term. Okay, so it got kind of a long one. Okay. So here is, if we did everything okay, the inside should just collapse, because I've got this right here minus this is just 0. Okay. So that's what I'm going to go ahead and do. I'm going to write remember, I had that 4 out there. Now I can go ahead and take the parentheses out now, okay? Because it doesn't affect anything. But just remember, initially you always want to try that. Oops, I'm sorry. The 2 is not under the radical. Actually, let me just write that down on another piece of paper. So that is going to be 5h over h . Okay, so I end up with that because the 4 actually goes away as well. Okay, because I'll have 5h plus 4 minus 4 over this. Okay, now I can cancel the h's out. Works great, doesn't it? Okay, so now I'm left with 5 So now I have this right here. So now I can notice how if I plug 0 in for h, I evaluate the limit, everything's okay. So now I'm going to evaluate the limit. Okay, so what do I get? I end up with 5 over square root of 4 plus 2 Okay, and that's just equal to square root of 2 plus 2 right there. Okay? All right, let's do another one. Do I have time? I think I'm going to have time. This is another typical example. Now this example is gonna require you to do some factoring. Okay, so right off the bat, if we plug, yeah, we get 1 minus 1 over 1 minus 1, which is 0. Okay. The numerator factors quite well, and you know, I'm going to ignore the limit for right now. Let's just work on simplifying this, then we'll take the limit. Okay, so I can actually simplify this. And by the way, when in doubt on breaking something down, factoring it apart, if you're unsure, there's nothing wrong with just going through here and refoiling it and seeing if you get if you end up with this. Okay. And now this right here, this is the one that confuses everyone, and this is one that's easy to forget. This is called a difference of cubes. You'll also see maybe a sum of cubes. I have it written down right here. Okay. In our case, we really have, I mean, you know, it's not explicitly listed, but this is x cubed minus 1 cubed. You know, 1 cubed is still just 1. Okay, so what we're going to do is we're going to use this difference of cubes formula down here, and with x being equal to a and 1 being equal to b. Okay, so I don't have it memorized. Okay, I don't recommend memorizing it. If you do enough homework, though, you'll probably accidentally memorize it. And I've also found that on test day, maybe you know, wear a pair of sandals to the test, and you can always write this on the bottom of your sandal. But I didn't say that. Okay, now let's see here. This is prime. This factor's prime, but this one can still factor out. Okay, I'm going to rewrite x minus 1. This factor is also prime. There's nothing I can do. If I have x plus 1 plus, or multiply by x plus 1, I'll end up with a 2x in there, so this is also a prime. Okay, so the x minus 1 cancels, and there's really nothing else that'll cancel. So let's go ahead. And now we'll evaluate the limit. Okay, and this is pretty. That just ends up 2 times 2 is 4, and 3. Okay, so as you can see, it's to your benefit to, you know, have really strong algebra skills, being able to factor, being able to, you know, algebra is really all about manipulating equations. It's kind of boring to learn, actually, but it's really for, you know, advanced math. You know, it's for simplifying things like that. So if you're unfamiliar with, you know, using conjugates, you know, you're factoring, sketching basic graphs, you're definitely going to want to practice and make sure, you know, you're really comfortable with that, because, you know, two things you don't want to get real stressed out in this class, and you don't want to get an F. So you know, hey, nothing wrong with going back and you know, I know we're all pressed for time, but just make sure you're in the class you need to be in. Okay, so thanks, and let's we'll take this even further. Okay, we're not even done yet, not by a long shot.